Hello everyone, welcome back to my channel. In this video I will show you how to calculate the optimum bond length, bond angle, and vibration modes of water molecule using Material Studio, and I will compare the calculation with the references. Yes, so let's get started. I have already started a new project, and we need to add some new file inside. So file, new, and 3D atom. Yeah, we can maximize the window here. If you want to restore the window, you can click here to restore the window. Yeah, we maximize the window and we want to put water molecule on it. So we move here to the sketch atom tool, and then you need to select oxygen. Yeah, if you left click once, and it starts the first atom, but it will not stop. And you can press ESC key on your keyboard, and then this is automatically only one atom. But this is very ugly. We need to change it to the ball and stick view. So you need to go back to this arrow here, and right click and display style and ball and stick. And this is a nice oxygen atom. And then we need to add a hydrogen atom. To add a hydrogen atom, you can either use the sketch tool here and change it to hydrogen, or you can just press here to add hydrogen automatically. And then we optimize the structure a little bit by this clean tool here. But let's go back to the selection here. But this is not a real calculation. Yeah, it more or less gives this a similar structure, but this is not a real calculation. So if you want to move the molecule around, you can hold your middle wheel on your mouse and then push around. Yeah. And if you want to zoom in and zoom out, you can rotate your middle wheel on your mouse. Okay, yeah, and then we want to do some real calculation to optimize the structure. What you need to use is something in the modules here. There are different possibilities. You can use Gaussian, you can use different things, but today I will show you this module called DMOD3. Yeah, you can access the module exactly from here, module DMOD3 and calculation. Another possibility is to access it in the toolbar here, and calculation. And then so basically the energy calculation is a single point calculation. It calculates the energy of the molecule. But what we want to do is the geometry optimization, so it relaxes the position of the atoms and try to find the optimum bond angle and bond length. So the functional here we choose GGA because it is a little bit higher level than this LDA here, and for example this BP. And then remember that you uncheck this use symmetry, although it is not important in the case of just frequency calculation, but since we are also let it do Raman calculation, so it's a good idea to just uncheck this use symmetry here. So for the electronics, we keep everything the same as default, and this is the basis set, and we don't change it. And also the properties, I check the frequency here, and also check the calculate Raman intensities here. Yeah. And for the drop control, it depends. If you have 4 CPU cores, it's good. It's good to use them. Yeah, for parallel computation. So this will make the calculation faster. Just press run. This will take a little bit of time, but in the end, this should be quite fast because it's just a small molecule. Okay, so now it's finished. And then we close this window and we go to this file called .xtd, and you can run the animation here. Yeah. So this is the animation that shows the initial state and then the optimum configuration. And you notice that it is oscillating, so we should select this stop at end here, and then run this again. And you see there is not much change because it is more or less at the optimum at the beginning. Okay, if you don't find this tool here, you can go to the tools. Oh no, sorry, you can go to view and toolbars, and then there is this animation. Yeah, if you select this, it is gone. And then if you select this again, it is there here again. Yeah. And then we want to measure the bound angle and bound length. You can select the tool here. Distance, we first measure the distance, and then let's see the angle 1, 2, 3. Yeah. So we just copy this to the Excel. 0.976 angstrom, and then for the other one it's 103.315. Yeah. So you see that the deviation is below 2%, which is quite good. Okay, and then we want to see what is the vibration mode. We go to the output file that is here, double click, and just maximize the window. You just scroll down to the bottom, and there is this frequency and Raman activity and Raman intensity. Yeah, for the Raman we don't we don't talk about here, but we can copy the frequency here. So those are the vibration modes, and I think you can also find it before that say it explicitly this is vibrational modes, but this is also okay. And you see that the deviation is below around 10%. Okay, so so in this video I've shown you how to calculate the structural optimization of water molecule, and also how to select the frequency calculation, the vibrational modes calculation inside using the module called DMO3. Okay, so I thank you for watching and hope to see you next time.